Hello everyone. So welcome to this lecture about machine learning, which form the basics of many modern AI systems. AI can be used in a wide range of applications. For example, this one. So you can try it by clicking links here. This is drawing games. So when you click it, then you ask you to draw some objects like the cookie, rabbits, watermelon. So before you finish the drawing, the AI system can already guess what you intend to draw. How can the AI system accomplish this? So essentially, it try to collect many examples of related drawing from different people. And then it will learn the patterns from this drawing, such as what the cookies look like, rabbits look like, and this allows the system to recognize new drawing. AI can also help people suffering from disabilities. For example, this is an AI system that help the people who cannot hear, but they can use this AI to help them communicate. You can watch this video clips about lip reading. So in that video, you can see the AI system analyze the movement of the mouth and try to understand what is spoken so they can help the deaf individuals communicate better in their daily life. So this is the videos.
Play red in X-ray zone.
Of course, the AI system can also make cars drive themselves. We call it the self-driving. In this image, it shows that the AI system can recognize the car, the road sign, and also the people so that they can decide whether it should move forward, backward, stop, right, or left in order to drive safely. Besides this, in medical field, AI can analyze the medical images to provide suggestions to the clinicians. And then in sports, it can analyze how different athletes perform, how well they are doing, whether the posture is correct or not, and give them some advice so that they can increase the chance to win. To do this, modern AI often make use of big data. For example, to recognize cars better, then they use large collections of car images. To analyze medical image, then they will need data from different patients. Okay, we have the data, and then how can they learn? This lecture contains three main parts. First, we will cover basic concepts in machine learning, including data, features, and key steps for applying this machine learning method. And then we will talk about different types of machine learning algorithms. And finally, we will teach on deep learning, one of the most popular types of machine learning used in many successful applications. We start with what is machine learning? Machine learning is a subfield of artificial intelligence. Under AI, there are many subfields. Computer vision, CV, natural language processing, NLP, and this one, machine learning. The aim of machine learning is to learn to perform a specific task from experience. Well, human, we learn from experience. Machine learn from experience that record in data. The machine learning system tries to learn how to perform a certain task and then we provide the data for them as reference. The nice thing is that okay, they can learn by themselves, then we do not need to tell them step by step how to do it. We do not need to write very detailed program to perform that task. Sometimes, I will say machine learning is just like cooking. Okay, if you have a good ingredient, you have a good approach, then probably you can produce a very yummy dishes. Let's take a look at it. We start with ingredients. For cooking, ingredients is very important. Ingredients for machine learning will be data. If you have a good data, then you have a good chance to get the good machine learning method, good machine learning model in the end. Data, just like ingredient for cooking, and we have different types of ingredient. Typical types will be numerical data. Well, for example, you have some sensor, then what you can get from the sensor, you will get temperature, you will get humidity. They are number, can we say numerical data. And other type, which is very common, then it will be the images. Images represented by array of pixel values. In the next line, then we will see one example to elaborate a little bit more. In addition, we have our audio record when you're talking about speech, music, or there is something like this, the wave going up and down. And of course, we have documents here, like the characters, words, and then organized in sentence, paragraphs. Also, we can have videos. And for social media, we will have the social network, which showing how the people are connected to each other, whether they are friends, whether they are family members. So the kinds of data. This example about the image, which is represented by a array of pixel values. Pixel, and first of all, is points of an image. And then it is represented by three numbers, red, green, and blue components. Well, you probably know that different combination of these three components will tell you the colors, right? So that's how we represent the colors of a point of an image. Then in this image, this region is represented by this set of numbers. So there are how many pixels? Here we have 20 pixels. We highlight one of them, and then the values will be 1, 2, 0, 50, and 25. Then it will tell you the color of this pixels. For this image, well, we can easily see that it is Earth. And for the machine, there are so many numbers. Which number should they use? So after we have this ingredient, just like this image, the next step will be processing. For cooking, what we will do after we have the ingredient, buy it from the supermarkets, then you will prepare it. You will slice it, you will peel it, right? So that's what you will do. Just like this, for machine learning, we will have to process or prepare the data so that we can make it ready for machine to learn. What does it mean by processing it or make it ready to learn? Then we have a step called feature extractions. We try to extract some features from the data, which is easier to interpret. For instance, suppose we have this two images, one from a cat, one from a dog, and if we look at the original RGB values, then there are millions of pixels. Well, it is hard to analyze. What we would like to do is we extract two features from each of this image. Feature 1 related to the eyes of the animal. You can see that the eyes look quite different, right? For cats and dogs. And the second features is about the spatial arrangements of eyes and nose. Again, you will see that it look quite different for the cats and dogs. Okay, so this is my idea. Yeah, there's two features. I think it will be good for classifications of cats and dog. And so I define the formula of these two features to produce the numerical values. So these are the two formulas. Well, don't worry. So it's actually quite simple. For this feature 1, I compute it by dividing area of iris by the area of eye. You will see that which one the value is higher. Dog, the values will be higher, right? How about feature 2? This time I put eyes to nose distance as the denominator. And in this way, the values of the cat will be higher. I try to put this features value on the 2D coordinate plane. The y-axis here as feature 1, and then the x-axis is feature 2. For a dog, which is this one, I use a red color for dog image. It will have a larger value for feature 1, while this feature 2 values will be smaller. On the other hand, for cats, feature 1 values will be smaller, and the feature 2 values will be larger. So now we have 2 dots, since we have only 2 images. We try to repeat that for more images of cat and dog. Then you will see that now they start to form groups. This group of cat and this group of dog. In those dog image, the values are close to each other. Those values from the cat close to each other, while we can see these two groups well separated. So we call this one the feature space. Okay, feature space. We start from the original data, get the image. We use the formula to get the feature values, and then we do it for every image, and we get this feature space. We say now the machine learning algorithm is ready to work on it. The machine learning algorithm can learn from this feature space to classify cat and dog. Designing good features is called feature engineering. And feature engineering. You want to design a good features for an application. What do we say by mean by this good features? The principle. Okay, we have 2 principles. The first one is if the 2 inputs share the same label, let's say both of them are dog, then we want to have similar feature values. And in case the labels are not the same, like cat versus dog, then we want the feature values to be as different as possible. And this step is very crucial Okay, having a good features are very crucial for a successful machine learning model. Before we go further, there are some important terms. A machine learning algorithm refers to the software that know how to learn from training data. Okay? So you can think of it as a recipe. It tells you how to cook, okay? Given the data and how to cook. And after we know how to cook, we cook it, and the final result, we call it the machine learning model. This is the more final dish. The receipt is the outcome, and then the dish is the resulting model. There are few points to note. So imagine two people, we have the same recipe. They may not produce the same dishes if they are using different ingredient. And just similarly, even the same machine learning algorithm can give us different model if the training data are not the same. On the other hand, even with the same quantity data, using different algorithm can lead to different model. And so in summarize, we have to pick the right algorithm, and we have to ensure the data quality is high if we want to have a good machine learning model in the end. This slide explains the key step of machine learning. First of all, we have to gather the data that we need. And we collect the data from different sources, but well, you have to ensure that we do it ethically. Second step, okay, we will prepare and process the data, including cleansing, okay, clean the noise, put it in the right format, and design the formula to extract the feature values. And then we will, well, partition it and use part of it, say 80% as the training data, and then 20% for testing. So we would like to do it because we would like to use the 20% to test whether the model can still perform well for some unseen data. Okay, after this, we have the data ready, then you will choose a right machine learning algorithm to use. It depends on the capacity, depends on the task that you would like to do. Then we choose a machine learning algorithm. And then we will code, which means we would like to train the model. We would like to train the models, and then we will evaluate it. Okay, evaluate the models, see whether it work well, okay, based on for example, the accuracy. You know how well it is. If it is not good enough, then you would like to repeat the previous step. Okay, maybe you look at the model, whether you choose the right one. Maybe you look at data, whether it is clean or not. Okay, you try to do it or tune the parameters. One parameters, we call it the learning weights. It control whether the model learns slowly or quickly. Okay, sometimes we want the model to go deeper and spend a longer time to train. And finally, we will have the suitable models, and then we can use it in productions. Okay, so hopefully you now understand the key concept of data, features, and some main stuff in machine learning. Next, we're going to discuss the major types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. So there's three types show how human learns. Sometimes we will have the supervisors, then we say supervised learning. Sometimes we have to explore by ourselves, then that's unsupervised learning. Sometimes we learn from trial and errors, and that is reinforcement learning. So that is how human learns. How about machine? We start with supervised learning. Supervised learning, it means the model learn from the taking inputs and also give a desired outputs based on example inputs and output pairs. Take an example. So let's say we have image of foods, apples and pears. You collect 1,000 images. And for each of this image, we got some inputs, which is this one. We have two features, color and shape. And then we have the output. It will tell whether that image is apple or pears. This form the labeled data set. Okay, labeled data, which means each of the data, we know the label. In this case, the label is apples or pears. In the previous example, the label is cat and dog. For each of this data, we know their label. And in this case, we have 1,000 data items. Well, again, the feature space, but not cat and dog. Now it is apple and pears. We paste it into the feature space and get this. This time green for pear, and then the red for apple. Feature 1 is color, and feature 2 is the shape. Okay, we use it as the Y and X axis respectively. So you will see that the pears form a cluster, and then the apple form another cluster. Okay, given this feature space, you can see that we can actually draw this line. We call it the decision boundary to put this, okay, to separate the apples and pears. Whenever the image is on top of this decision boundary, then we will classify it as pears. If you have a new image which is below this decision boundary, then we will classify it as apples. Okay, drawing this line for us is quite easy, right? But then for supervised learning, this is the task of the machine. Okay, based on the numerical values, they will have to find this line, which can well separate the data of different classes. And then how the machine learn without labels? Unsupervised learning try to discover pattern and rules without knowing the correct labels. So you may say that it is very hard to learn, but actually even baby can learn without labels. So for babies, they cannot speak yet. Okay? The parents cannot tell them what is days, what is light, but by some observations, they will know that okay, when it is light and noisy, then this is time. Okay, this period of time, they can eat and play. If it is dark, then and quiet, then they have to sleep. So even no one tell them, by looking at this kind of pattern, they will be able to put this find out this two period of time. Let's go back to feature space. Okay, so given this feature space, you may see that we don't have the color because we don't have the label. Okay, all the data point in the same color because we don't have the label. And then I tell you, okay, tell me to put this data into two groups. Then certainly you will put it this way. Put this point into one group, put this points into another group. So why? Because we will consider the closeness of those points. We try to put the points that close to each other as one group, and then this point close to each other in another group. So even we don't have the label, by looking at this, the distance, the distribution of them, we will be able to put it into different groups. We call this the clustering. Okay? Clustering is kind of this unsupervised learning. There are some applications that we can do with this clustering. For example, we have lots of photos. So now we take photos anytime, anywhere, but we don't have time to tag them. Then we can make use of clustering. Okay, clustering can help us to put those photos of the same person into groups. Okay, based on who appears in the photos and then group them. And so, well, my daughter, say, photos into one group, okay, my parents' photo into another groups. Then this can help us organize the photos without labels and easier to find the useful one and useful photos. Another examples is movie recommendations. I think we know Netflix. Okay, Netflix has a database with the history of all the users. And well, based on what they see, okay, the users who watch similar types of movies can be grouped together. And so one user in that group watch a movie, then this movie will be recommended to other group member in the same group, because by clustering, somehow we will think that all the users in the same group with similar preference. If one of them like it, probably other people in the same group will also like it. And you can see that this process is being done without any labels. Okay, and not just another applications. The third type is reinforcement learning. Reinforcement learning focuses on performing actions, making decisions in an environment to maximize some long-term reward. And it is done by trial and error. We just keep trying to find a good way to get a higher reward. Just like you learn chess, and then you will play it with different people, okay, many times, and eventually, gradually, you will learn a better move. Okay, based on whether you win or lose, you probably will find out, okay, this kind of move can help me increase the chance to win, then you will do it. And that's reinforcement learning. Another example is writing essays. Okay, let's say you submit the essays and then the teacher just give you the grade without comments. And if the student can improve just simply by looking at the grade, find out how to get a better grade, then that is a form of reinforcement learning. Okay, so there are three types of machine learning. So we just covered. If we use we have labeled data, then that's supervised learning. If we don't have label, unsupervised learning. And if it's reward-based trial and error, then that is reinforcement learning. And finally, we discussed deep learning, one of the most widely used machine learning algorithm today. Deep learning is often viewed as a move from just a code to being achieved because of this more advanced, very powerful. If you still remember in week 1, we have the slides, and then deep learning follow the connectionist approach, which inspired by how our human brain works. Let's take a look at our brain. Our brain have many neurons, okay, just like this, neurons. And then it is a very special type of cell which take stimulation signal, and is triggered, we send our stimulation signal as outputs. And they are all interconnected. What does it mean? It means that the input of the outputs of a neuron will become the input of another neuron. And so it forms a network. And then the strength of the connection, it depends on the experience and use. And to building up this kind of connection is what we say learning. Okay, to tune the strength of the connections. And then the ANN, and then deep learning try to mimic this process with something called the ANN, artificial neural network. And they connect, it contains many artificial neurons. So this is one artificial neuron. And for ANN, then they have many neurons that organize as layer. So this is input layer, and then we have some hidden layer, and there's the output layer. So organized in layers. And deep learning is actually the ANN, but then we have many layers, okay, going deeper and deeper. And that's deep learning. This deep learning models with many layers will help us to capture very complex patterns. So why this deep learning is so powerful? We can take a look at this example. Again, the 2D feature space. If you look at this example, then you will find that it is impossible to find a straight line that perfectly separates the two classes. No matter how you draw the line, some of the points will be misclassified. Like in this case, you will see those red dots. It used to be at the left-hand side of the line, but then now it is at the right-hand side. And deep learning can help us, deep learning models. It can help us to draw the feasible decision boundary so that we can well separate complicated high dimension data. And that's why it is so powerful. Well, it is so powerful, and so it also required more resources. If we use cooking as an example, then it will require a bigger kitchen. Which means cloud computing. In pedagogy, this deep learning is benefit from large amounts of data, big data, and also the very good model, say the big deep learning model, which required high computational power. If the data set is small and your model is small, the problem is not that complicated, you can do it. You can do the machine learning process with your own computer. But then, if the problem is very complicated, you have many data, the model is very complex with many layers, many neurons, then probably you need to buy the service from different kinds of service provider like Google, like Meta, like Amazon, to give you enough computational power and storage. So big data, complex model, powerful computation will make this deep learning effective. In summary, the machine learning learns from data to perform tasks without needing explicitly programmed instructions. So that's machine learning. We have covered some key steps of machine learning, like this, shown in this image. We also learned the types of machine learning: supervised, unsupervised, reinforcement, and then we learned what deep learning is. It uses many layers of artificial neural, and it is very powerful. In the lab sections, you will have the hands-on experience on how to collect data, how to train the model, and how to use them. Okay, so here are the reference, and thank you. Bye bye.